Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in our today's mathematics session. So children, in our previous session we have learnt about probability part 1, isn't it children? So it was a completely new topic for you, right? So we have learned some basic concepts in probability. So children, today we are going to do the next part of that lesson. Let us see children. So today we are going to deal with probability part 2. So by the end of this session, you will be learning basic concepts in probability. Apart from that, we are going to apply probability in solving few problems. So let us start our session children. So before that, let us quickly recap what we have done in our previous class. Let us see children, what is a random experiment? That is the right answer children. In an experiment, the results are known well in advance, but the result of the specific performance cannot be predicted. For example, tossing a coin and also rolling a dice. You know the outcomes of this experiment, isn't it children? That is, when you toss a coin, you may get head or you may get a tail. Similarly, when you roll a dice, you may get 1, 2, 3, 4, 5 or 6, isn't it children? So these are known to you, the results are known to you in advance, but can you predict children what exactly it is going to come? That is not possible, isn't it children? So we call this as a random experiment, that is, tossing a coin is an example and rolling a dice is another example children. Now children, what is meant by fair and unbiased? So if you notice, when we toss a coin or even roll a dice also, we assume that the coin as well as the dice are fair and unbiased, which means for each toss or maybe for each roll of the dice, the chance of all the possibilities is equal. That means, if I toss a coin, the chance of getting head is same and also the chance of getting tail is also same. Even if you roll a dice, the chance of getting 1 or 2 or 3 or so on up to 6, all these have equal chances. Then we say it is a fair and unbiased, maybe it is a coin or maybe it is a dice. So in our topic children, we say a coin or a dice, it means a fair coin or a fair dice, okay children. Then what are equally likely outcomes children? So there are certain experiments whose outcomes have equal chances of occurring, and outcomes of such experiments are known as equally likely outcomes. Just now we have seen, like tossing a coin, chance of getting head is same and tail is same. So they are equally likely outcomes children. Now let us see what is meant by a trial children. So any particular performance of a random experiment is known as a trial, that is, tossing a coin or even rolling a dice. So each toss of a coin or each roll of a dice is called a trial, okay children. Now let us see what is meant by an event. An event is a collection of specific outcome or some of the specific outcomes of an experiment. Now let us see what actually a probability is children. So probability is a branch of mathematics which deals with the numerical description of how likely an event is going to occur. So the formula to find probability of an event is denoted as P of A, and it is given by number of favorable outcomes for the event A divided by the total number of possible outcomes. Got it children? So this is the most important formula we have in probability, and this is the one which we are going to use in all the problems that we are going to discuss further, okay children. Now take a look at the image shown on your screen. What did you notice children? Yes, here we see that two identical coins are tossed simultaneously. So we have seen when a single coin is tossed, what are the outcomes children? Yes, you get a head or you may get a tail. Now, suppose when 2 are tossed, now what are the possible outcomes, children? Let us see. So, we have 2 coins here. Now, when I toss these 2 coins at a time, then I may get head in first coin and also head in another coin, is not it, children? So, both heads we can get, or I may get head in first coin and tails in the second coin. Not only that, even I may get a tail in the first coin and head in the second coin, and finally, you may get even 2 tails, that is tail in first coin and also tail in the second coin. So, these are the 4 possible outcomes, children, that is both heads, first head second tails, first tails second head, and both can be tails. Now, let us see probability of an impossible event, children. So, the word itself says, children, it is impossible event, means which is not going to occur, is not it, children? Let us take an example for this. So, what is the probability of getting 0 on rolling a dice? So, children, when you roll a dice, you get 1 or 2 or 3, 4, 5 or 6, any one out of all these things, right. But do you notice any 0 on this dice? No. So, the total number of outcomes are 6, and what is our favorable outcome, children? 0, because here there is no 0 over here. So, the number of favorable outcomes will be 0 only. Now, let us apply the formula of probability, that is number of favorable outcomes divided by the total number of possible outcomes. So, your favorable outcomes are what, children? How many are there favorable outcomes? 0. So, that means P of 0, that is probability of getting 0 here, is 0 divided by 6, we get 0. Hence, we can say that the probability of an impossible event is always 0. So, let us move on to another important concept, children, that is probability of a certain event. Again, here you can see the word certain event, means it is going to happen compulsorily. I can say it is a sure event, right, children. So, let us take an example. What is the probability of getting a number less than or equal to 6 on rolling a dice? So, we have seen already the total number of outcomes are 6, and here how many number of favorable outcomes we have, children? Yes, we have same 6 favorable outcomes, because see a dice, what is the outcomes we have? 1, 2, 3, 4, 5 or 6. Now, all these numbers are less than or equal to 6. So, that is why our number of favorable outcomes are 6. Now, again we will consider the formula of probability, that is number of favorable outcomes divided by the total number of possible outcomes. Now, let us substitute the values, children. So, the probability of what? Getting a number less than or equal to 6 is given by 6 divided by 6. So, what do we get, children? Yes, we get 1. That means, what do we conclude? Probability of a certain event is always 1. So, children, we have seen some basic concepts that we have already learnt also, but just we have quickly revised what we have learnt in our probability part 1. Now, let us see few applications of probability in our day-to-day life, children. Let us see the first one. So, children, in generally weather prediction, meteorological department predicts the weather, right? How do they predict the weather? They just use the concept of probability only, children. So, this is one of the important applications that generally you might be seeing in news channels and all, right, that today it may rain or tomorrow it might rain, or there will be high temperature tomorrow or day after it will be very hot. So, all these things, that is they predict using the concept of probability only, children. And the next one is about insurance companies, children. That is, these insurance companies, they calculate premiums, like how much amount we need to pay. That all will be calculated based on probability only, children, again. So, this is also another important applications. And finally, if you notice about exit poll. So, generally during elections time, you might have heard this word exit poll. Now, what actually they will do here? So, after the elections are over, so a survey will be conducted where some people will be inquiring about the voting, to which candidate they have voted and all. And based on the data they collected, they are going to find the chances of winning of a particular candidate. So, this is done purely based on the concept of probability. So, children, till now we have seen some of the concepts that we have already learned and also the uses of probability in our daily life. Now, it is time for us to apply the concept of probability in solving few problems. So, children, let us start with the first problem. A bag contains 5 green marbles, 3 blue marbles, 2 red marbles and 2 yellow marbles. Now, one marble is drawn out randomly. Now, the questions are the 4 different color outcomes equally likely? Explain. And second one is, find the probability of drawing each color marble. And finally, we have to find the sum of their probabilities. So, let us start the solution, children. So, the first question is, are the 4 different color outcomes equally likely? Let us see. So, children, if you notice here, the 4 different color outcomes are not equally likely, but why? Because they are not equal in number. If you notice, there are 5 green marbles and how many blue marbles, children? 3, and red are 2 and yellow are also 2. That means, they are not in equal number. That means, the chance of getting these colored marbles are not same. That is why they are not equally likely. Okay, children. Let us move on to our next question, that is, find the probability of drawing each color marble. Okay, children. Let us see that. So, total number of marbles are how many? 5 green plus 3 blue plus 2 red and 2 yellow, and adding all these things you get 12. So, this is our total number of marbles, that is nothing but the total number of outcomes, I can say. Now, let us find the number of green marbles, which is 5. So, probability of an event, again the same formula we are using. Now, probability of getting green marble is given by, yes, the favorable outcomes, that is 5 divided by 12. Now, let us find the probability of getting blue marble. So, that is given by, how many blue marbles are there? 3 and total 12. So, it is 3 by 12. Now, 3 by 12 can be simplified further and we get it as 1 by 4. Next, we will find out the probability of getting red marble. So, how many red marbles are there, children? 2. So, total 12. That means, probability of getting red marble is 2 by 12. On simplifying this, we get 1 by 6. Now, finally, we will find out the probability of getting yellow marble. So, number of yellow marbles are again 2 divided by 12. On simplification, we get probability of yellow marble as 1 by 6. So, that means, we got P of G is 5 by 12, P of B, that is blue color, 1 by 4, probability of red color 1 by 6 and probability of yellow is also 1 by 6. Now, let us see the third question, children. Find the sum of their probabilities. That means, we have to find P of G plus P of B plus P of R plus P of Y. Now, let us substitute all these values, children, here, that is 5 by 12 plus 1 by 4 plus 1 by 6 plus 1 by 6. Now, we are going to add all these fractions. So, for that we will take LCM, that is 12. So, we get 5 plus 3 plus 2 plus 2 by 12. So, what do we get, children? On simplification, we get 12 by 12, which is equal to 1. That means, hence the sum of the probabilities is always 1. So, let us move on to our next question, children. Here a letter is chosen from English alphabet. Find the probability of letters being a vowel, a letter that comes after P, a vowel or a consonant, and finally, the last one is not a vowel. Now, the first question is, we need to find the probability of getting a vowel. Now, children, what are vowels? Tell me. Yes, you are absolutely right. A, E, I, O, U. These are vowels, right, children? So, how many are there total? 5 vowels. That means, this is our favorable outcomes, that is 5, and the total outcomes are 26. So, probability of getting an event E is equal to number of favorable outcomes divided by the total number of outcomes. So, here what is the probability of getting a vowel, children, then here? Yes, P of getting a vowel, that is probability of getting a vowel is equal to favorable outcomes 5 by total outcomes 26. So, we get 5 by 26. So, understood children? This is how we find the probability of getting an oval. Now, let us move on to our next one children, that is a letter that comes after P. That means, what all the letters which are after P, what is the probability of those letters that are going to come? That is what we have to find children. So, we know that P is 16th letter. That means, after this letter, how many letters will be there children? Yes, there will be 10 letters. That means, this 10 is our favorable outcomes. So, again in the probability of getting an even formula, we will substitute these values, that is probability of a letter that comes after P is equal to 10 by 26. On simplification, you get 5 by 13. So, next we will see probability of getting either a oval or a consonant. So, number of ovals we have seen already. How many children? 5. And how many consonants are there? Yes, you are right. They are 21. So, what is our favorable outcome children then? Yes, number of ovals plus the number of consonants, that is 5 plus 21 gives us 26. So, probability of getting an oval or a consonant is given by the number of favorable outcome, that is 26, divided by the total number of outcome, that is again 26. This on simplification you get 1. So, the probability of getting either a oval or a consonant is 1. Now, let us move on to our final bit children, that is probability of not getting a vowel. Let us see. So, children, here number of vowels we have already learned, it is 5, right children, and probability of getting a vowel is 5 by 26. We have already seen this. Probability of getting a vowel plus probability of not getting a vowel is 1. Now, from that relation we get probability of not getting a vowel is always equal to 1 minus the probability of getting a vowel. Now, we know already probability of getting a vowel, right children, that is 5 by 26. Now, let us substitute the value children here. We get 1 minus 5 by 26. Taking LCM you get 26 minus 5 by 26. This gives 21 by 26. So, this is the probability of not getting an vowel. So, let us move on to our next question children. What is the probability that a randomly thrown dart hit the square board in shaded region? So, here we are going to take pi is equal to 22 by 7 and we express the answer whatever we get in percentage. So, children, here you can notice this is square board, on this we have a dart board, circular dart board, and this is the shaded region, this is in blue color, right, and we need to find the probability of the dart hitting this shaded region, and the radius of the circle is 2 centimeters. Let us start with the solution children. So, given radius r is 2 centimeters. So, for this first of all we need to calculate the area of the shaded region. So, to find this area of shaded region, what we should do? Yes, we need to find first area of this square, then area of this circle, then find the area of shaded region, which is area of square minus area of the circle. Now, let us find out area of square children. So, for that we should need first the side of the square. So, side of the square is 4 centimeters, but why it is 4 centimeters children? Because the radius of the circle is 2 centimeters. What is its diameter? 4. So, here the diameter of this circle is nothing but the side of the square. So, that is why we have square side is 4 centimeters, and we know that area of a square is side into side square units. So, now apply the value of side here, we get 4 into 4, that is 16 square centimeters. Now, let us find the area of circle. It is given by pi r square square units. Now, let us substitute the value of pi as 22 by 7 and r is 2. So, we get 22 by 7 into 2 into 2. So, this on multiplication we get 88 by 7, on dividing 88 with 7 we get 12.571 centimeter square nearly. So, area of shaded region is area of square minus area of circle. So, now let us substitute the values children here, 16 minus 12.571. So, subtracting this we get 3.429 centimeter square. So, this is the shaded region. So, this is nothing but our favorable outcome, that is 3.429 square centimeter, and the total outcomes are what children? that is nothing but the area of square, okay, that is 16 square centimeters. Okay. Now, let us apply the formula of probability, that is probability of an event is number of favorable outcomes divided by the total number of outcomes. Now, let us substitute the values here. So, 3.429 divided by 16. This on simplification we get 0.214 nearly again. So, let us convert this into percentage, children. So, what will you do? So, 0.214 I can write it as 214 divided by 1000 into 100. On simplification you get 21.4 percentage. Okay, children. That means the probability that a randomly thrown dart hits the square board in shaded region is 21.4 percentage. I hope you understood the problem clearly, children. Okay. Now, let us move on to our next problem. The following table gives the ages of audience in a theatre. Each person was given a serial number and a person was selected randomly for the bumper prize by choosing a serial number. Now, find the probability of each event. So, I am going to show you what are the events. So, here the table is given, you can see the table, children, age is mentioned here, and how many are there in the audience who are male and female. Now, let us start with the solution, children. So, first of all let us find out how many audience are there on the whole, that is number of females plus male. Now, adding all these number of males and number of females we get 505. So, that is the total number of audience. Now, let us see the first question, children. The probability of audience of age less than or equal to 10 years. That means, who will get the bumper prize in this age limit, that is less than or equal to 10 years. First, we need to find the audience whose age is less than or equal to 10 years. Now, from the table if you notice, now these two rows if you consider, these two rows shows the audience whose age is less than or equal to 10 years. Now, let us find the sum, children, that is 3 plus 5 plus 24 plus 35. What do you get? You are right, it is 67. So, this will become our favorable outcome. So, probability of audience age less than or equal to 10 years is 67 by 505. So, let us move on to our next question, that is probability of female audience of age 16 years or younger. So, children, here we are going to find what? Female audience whose age will be less than or equal to 16 years. So, here again in these 3 rows, that too only in female category we will see, children, because the question is the probability of female audience of age 16 years or younger. So, we take only female audience here, that is how much? 5 plus 35 plus 53. So, let us add these numbers, children. Yes, you get 93. So, this is a favorable outcome. That means, what is probability of female audience of age less than or equal to 16 years? Yes, our favorable outcomes is 93 divided by the total outcomes, that is total number of audience 505. So, this is the probability of say getting bumper prize by female audience whose age is less than or equal to 16 years. Next, move on to our next question, children. The probability of male audience of age 17 years or above. So, again here we are going to check the male audience only whose age is 17 years or more than 17 years. Now, let us find out the number of audience, children here. So, in this if you notice here we have 17 to 40 years, 41 to 60 and over 60. Now, these all are males whose age is more than 17 or equal to 17. So, let us add this number of audience here, that is 121 plus 51 plus 18. What do you get, children? Yes, 190. Now, this becomes our favorable outcome. So, probability of male audience of age greater than or equal to 17 years is equal to the favorable outcomes 190 divided by 505. So, on simplification you get 38 by 101. Now, move on to the next one, that is probability of audience of age 40 years above. So, here again we will see the entire audience, that is males and females together whose age is above 40 years. That means the last 2 rows. So, what do you have the total number of audience? Yes, 51 plus 43 plus 18 plus 13. you get 125. So, the probability of winning a bumper prize by the audience of age above 40 years is 125 by 505, or simplify this further and we get 25 by 101. Let us move on to our next one, children, that the probability of person watching the movie is not a male. That means, we need to find the number of persons watching the movie who is not a male. That means, only females, right children. So, let us find the female audience strength, which is 5 plus 35 plus 53 plus 97 plus 43 plus 13. This gives 246. So, this is our favorable outcome. So, the probability of a person watching movie is not a male is 246 divided by 505. So, children, I hope you have understood the problems very clearly. Okay, children. So, this is how we use the concept of probability in solving few problems. Now, children, before we exactly conclude our today's session, let us quickly recap what we have learnt in our today's session. Let us see, children. An experiment is an action or process that results in well defined outcomes. There are certain experiments whose outcomes have equal chance of occurring, and outcomes of such experiments are known as equally likely outcomes. A trial is an action which results in one or several outcomes. An event for an experiment can be defined as the collection of some outcomes of the experiment. Probability of an event A is given by the formula number of favorable outcomes of event A divided by the number of total possible outcomes, and the probability of an event which is certain or sure, that is 1 always, and the probability of an event which is impossible or probability of an impossible event is 0. The probability of an event always lies between 0 and 1, and both 0 and 1 are inclusive. You know, children, because 0 is for impossible event and 1 for the sure or the certain event. And finally, the sum of the probabilities of all the outcomes of a random experiment is always 1. So, children, before we conclude, I would like to give you few problems based on the concepts that we have learnt already, and also some of the problems we have done in this session. You please do these problems and submit to your mathematics teacher. Let us see the first problem, children. A bag contains 2 red balls, 2 blue balls and a yellow ball. Raj takes out a ball from the bag without looking into it. What is the probability that he takes a yellow ball, a red ball and a blue ball? The second question is, what is the probability of getting a number greater than or equal to 4 when a dice is rolled? The third question is, Vasisht tosses 2 different coins simultaneously. What is the probability that he gets at least one tail? A coin is tossed 60 times and the following outcomes are recorded. Number of hits are 28 times and tails 32 times from the experiment. Now, compute the probability of each outcomes, and the second question is, find the sum of probabilities of all outcomes. So, children, with this we have come to the end of our mathematics digital class. I hope you have learnt all the concepts clearly, and also now you are confident of applying the formula of probability in solving few problems. And children, do not forget to do these problems which are given as assignment and do submit to your mathematics teacher. So, children, we will meet in our next digital class. Until then, goodbye, take care and happy learning.